2006 Honda CRV air conditioning problem. Customer states AC not working. Well, as you can see, I already started some diagnosis. There is no reason for me to take you through this. It is fast paced. There's nothing to think about. It's a very simple circuit. So first thing I did, I come up, confirm. It does not cool. Correct. No cooling. Is it no cooling because we lost pressure? So after doing a visual, I have pressure, 98 psi, 97 psi, whatever it is. I have more than enough pressure in the system to close any safety switches. I should be working. It's a Honda, it's an Acura. We know relays go bad. Very common on these. So without testing, you jump to conclusions and you go, okay, it's a relay. We pop off the box. We look inside here. And what do we see? We see the snowflake symbol with a fan. That means this relay is when the air conditioning's on, that radiator fan comes on, and we have that radiator fan come on. Then we have a horn. So here's our horn, here's our radiator fan. Then we have another radiator fan. It's right there. So do we have it on? Anyway, you can't see it in there, but no, it's not on. But that's not our problem. Our AC is not coming on. So then we just have the snowflake with a relay right there, and that's this one right here. So okay, it must be bad. So I take it up and I push it in and out, and I could feel it. I don't know if you could hear that click in the phone, but it's clicking. Clicking doesn't mean it's good. Clicking just means the contacts are opening or closing. You could have a lot of burnt oxidation with a lot of resistance and you're not passing current. So that doesn't mean the relay is good just because it's clicking, but it is telling you the signal is going through all the safety pressure switches, through the dash, it's getting all the signals, and it's grounding. See the little ones? See the big ones? See the big copper ones? See the little brass ones? I hope you know the difference between copper and brass. Okay, so the little ones are just signal. All those are doing is energizing an electromagnet, and that's all it's doing, so it could bring that contact close. The contact is just shunting over your high current that is going to pass the current and the voltage to the field coil, which is a large electromagnet that pulls in the clutch. Think of it as nothing more complicated than a light bulb. You just have a light bulb over there you're trying to turn on. So we're doing that with no fancy equipment, nothing expensive, nothing but your brain. We're lucky here because these are all the same. So let's say we want to make sure this relay is good or bad. So you come over here, here's a horn. So there's a horn relay here. Does the horn work? Horn works. So that means you got a good relay. So let's pull out the AC, throw that to the side. Let's pull out the horn relay. Horn relay. It clicks, it's going. We know the horn relay is good. Okay, we could get that out of the scenario that it's good or bad. Do we have power? You don't need an expansive fancy thing like this. This is only a 12-volt circuit. In this circuit, there's nothing that you're going to damage with a test light. If you use the headlight bulb as a test light, you can do this. So, and it would help if I left my thing connected. So we got 14.1 volts there. When that clicks and goes over, it passes to the other side. But look, now think of this circuit. I'm having nothing. What I should have is this. Let me speak. I should have that, the 0, and a green light, because this is the positive side that comes from one of the fuses over here. I already checked the fuses. We're not going to waste our time doing that. And we know we have power here anyway. But over on this side is the wire that continues all the way over to what I'm calling a light bulb. Okay, so let's look at this in a different light. Because here's our relay. This is representing our two tangs, copper tangs, the big thick ones coming down out of a relay. It goes up like that, it goes over like that. It has a contact point there, and it has a contact point there. They are not touching. The little brass ones, low current, all they are is a piece of iron. Think of a nail that you nail in a house, And if you take a piece of wire and you wrap a piece of wire around a wire and you connect it to like a 6-volt battery, you just made a magnet. Well, let's put a piece of iron right there, and when you press the button on your dash, all you're doing is putting a little voltage here, and this one's going off the ground, and all you did was you just turned this into a magnet. That magnetic field pulls on this piece of iron right there in a downward motion. When it goes in a downward motion, these contacts close. When these contacts close, now you have a closed circuit. They go over to the field coil. You know what a light bulb looks like, right? When you do a light bulb, you go up like this and it has a little filament in it, and it goes on site and it shines bright. All you have is another magnetic coil over here. When you close these magnetic coils here by energizing this, you just close these contacts. You just energized over here. But actually, I drew this wrong. Sorry, I made a mistake. Wow. Let's kill this. This goes right to ground to the engine block. Wow. Okay, let's get retarded here. Having a Alzheimer's senior moment. And this side, let's say, goes to ground. Okay, let's kill all this. And I'm not reshaping this video. I'm leaving my mistakes in here. Okay, so none of this is there. This goes to ground chassis, this goes to ground chassis. Let's say it does that, not back to an ECU. We're gonna make it real simple. So all you did was made this little magnet. You pulled this little piece of iron down that had the contact on it that goes down. This comes down like that. Now you just completed this circuit, and you went down to the clutch coil field face right here. Okay, and then you have the pulley. Remember, okay, so there's the clutch coil. Then you have the pulley that is spinning, correct? And here's your, let's say, your little valve belt grooves inside there. Well, inside here you have a big, let's say a coil of wire is in a resin cast inside there, and one wire comes out and it grounds to the engine block, and another wire comes out and it goes to this power wire, what's 12 volts coming in, comes in, and it goes to this wire right here, 12 volts. Okay, and all you did was put 12 volts through this little copper tag right here. Let's say the power goes into this one, 12 volts, has your current. These little contacts close. When they close, then the power comes out, and I'm going out and in. I'm not thinking of electron force or anything like that. I'm keeping it conventional. We're not gonna, this is no science class. And so the power goes out and it goes around this coil that's around a piece of iron, and it just made a giant magnet. And when this becomes a magnet, you remember you talk about magnetic flux that gets strong when you were in 6th grade science class, and you put a piece of iron plate right here. The iron plate sucks to the magnet like that, and that's connected to your shaft. So that's all you're doing. A very, very simple little thing. This is nothing more than a light switch on your wall. Think of it as that simple. So this is Electro 101. This is actually the simplest that I can make it, and try not to make it complicated. Please don't think because I have this $200 item here you need anything like this. For this you could use a simple test light, a simple headlamp, a simple cheap $7 test light on this to find out whether you have power or not. And over here, if you wanted to know if this was contacting all the way through, you would take this and this, just reverse them. What am I thinking? Okay, here's what you could do. If I wanted to know if this was going all the way through, I could take a small light bulb that doesn't need any current, and I could have went down into the one, this wire goes all the way to the coil, and you could take it from there with a small amperage and go right to the positive, and you would see it glow. If it didn't glow, you have a complete open. Now this is only if you have a complete open. We still don't know, the wire could be bad over here. So let's go over to the wire. Let's make sure I'm hooked up, because I'm just having a message popping up on my screen right now saying what time am I going to be to the next job? I'm supposed to be there in about 15 minutes, and I'm not going to be there. So let's go down here. So what I noticed, there was a lot of new clips all over here. Somebody worked down here. When I see something where it looks like somebody worked, I get suspicious, because there was brand new clips with no dust on them. Sometimes they hit the wire. So now we're under the car looking at the compressor, and I'm trying to talk and record at the same time, and here's our connector right here. Okay, so when I was on, I was getting power past the plug. When I tapped in past the plug, because when you take power, you don't always want to take power on the side of your relay or something like that, because where's my thing? I'm trying to see. Where am I at? Sorry guys, this is a horrible video, but here's what it is. So here's your connector, what I'm hitting right here. This is the wire from the relay. You can easily have power here, but somebody could have yanked on the relay and the wires could be pulled out from inside and not touching, or they could be corroded and you have no power on the other side. So what you want to do is you want to check for power on the other side. And I do have power on the other side in this wire. There is power here. And this wire goes directly over to the compressor. And there's no safety temperature cut off or anything like that. There's nothing in the way. That wire goes directly into the field coil, and the field coil is inside there, and it grounds on the other side. And when I ohmed it out, so on the other side it should be the ground, and it's not the ground. And I got that because, here we go, it's not green. It should do this. If that field coil was closed and grounded, I should be getting a ground right there. Another way you can test it, if you really want, now you should go down to the component because you could have a bad wire in between. But we know I went to the other side of the connector and it was getting power, but here we go. I'm going between power, no, not power. I'm going between the ground of the field coil and the chassis ground. Okay, so I'm hooked onto that bolt there, and I'm going to the fuel coil right there, and I got out of limit. If I went to, let's say, what can I use? Here's a horn. A horn is electromagnet. So I should have ground on one side. There's our power. Just like here on the field coil, we have power on the horn. The horn is an electromagnet, just like the field coil on the clutch. That one right there. See that zero? Because it's grounding all the way through. So if I take that, 0.06 ohms. That is the resistance of the winding inside the horn. So a horn vibrates the exact same way. And I lost my thing somewhere. So a horn is exactly like this. It's an iron core, and it has a magnet around it, and the flux vibrates, and it vibrates those two little pieces of metal, and it makes the horn sound come out of it. But it still has a ground, and it gets B+. Same exact thing, and you have a certain amount of ohms of resistance going through that winding. Here you have the same thing. You have that coil, and you have a certain amount of resistance going here. This would be like for a light bulb. And you have this field coil here, and you have a certain amount of ohms. We are getting zero, complete open when we test. Nothing happens, out of limit, because it's open. There's an open coil. So without taking the coil out, without disconnecting the wire, now the wire could have been a problem, but I did test on the other side of the connector. You don't want to test on this side of the connector connected here, because the connector could be bad. I tested on the other side connected to the coil, and I still had power going through with no problem. That is a simple, fast way to diagnose that you have a bad field coil. Oh, another thing you can do too, there's the old magnetic screwdriver trick. If you have a piece of iron and you energize that up there without the engine moving, you put 12 volts to it, and if you have a piece of iron, this is stainless steel, let's pretend this is a screwdriver. If I put this right there and that was a magnet, you would feel a small iron screwdriver pull in. Another way you can do it is if it was energized and you had a large clutch gap, and you only use a piece of wood or anything like that, but you would push on the tap on the coil right there, you would push it in. Now if I was energizing this with the engine off, there would be no rotating parts and I could put my hand in there. But if you energize that coil with the engine off, it pulls in the coil. If you had a very large clutch gap, it would not pull in the coil, and I could physically see the clutch gap's not that large. But if I energize that coil with the engine off, no rotating parts to get my fingers or anything like that, you would push in on the clutch, and the clutch would pull in because you pushed in the gap, and then it would pull in if the coil was moving. But we don't have that scenario. We have an open inside the windings of the coil. So after you're seasick watching my very jiggly video with bad audio and making some diagram mistakes, this is a one-take shot with no editing. That's what you get. I hope you can understand. But we got the clicking going on. We changed the coil with the horn. It still did not go on. I confirmed there was power on the other side of the connector, on the other side, not on this side of the connector, but past the connector, because the connector contacts could be bad. I confirmed there was power on the side. I confirmed that there was no ground. It was a complete open with this. I confirmed there was actually no circuit open. I went to ground, and I went to the ground side of the field coil through the field coil, and it was out of limit. There was actually a complete open. So I confirmed several different ways that that magnetic clutch coil is not working. And remember, this is no more complicated than the simple contacts of a light switch on your wall, and that field coil that's inside there, that magnet, is no more complicated than the little piece of filament in a light bulb. Nothing magical in there, no circuit boards, no electronics, very analog in an inductive force kind of thing, like a heater element. That's all it is. All right guys, next video, and I will be recovering the refrigerant out of this one. They'll be replacing that clutch coil, and if this has something like 200,000 miles on it, so they'll probably be doing the whole engine or the whole compressor. Yeah, we're 183,000 miles. They'll probably be doing the whole compressor instead of risking it and putting on a coil, because the magnetic field coil and the whole clutch assembly and everything like that is probably about $50 difference in price from a whole brand new assembly to put on here. So it's not even worth the labor to separate the two halves, and then risk the work of having a leaking shaft seal 3 months later or something like that coming back on you, or a compressor. To the next video. See you guys.